This is worksheet 16A, and we're going to start analyzing graphs with polynomial functions. Where it says to just draw a rough sketch, I'm actually going to draw it based on what we're seeing, and I'm going to find some key points. It doesn't have to be perfect, but I think we should look at where the turning points are. That means where the graph changes directions, and of course the end behavior. Determine if it represents an odd or even degree function, and then find the zeros. The zeros will be, of course, the x-intercepts, and we will round to the nearest hundredth. That's 2 decimal places. Find the relative max and mins, and I'm rounding to the nearest hundredth. Find the domain and the range. Okay, so you should be in your grapher getting this typed in, if you haven't already, and looking at the graph. I'm going to hit zoom 6 so that we all have the same window. If you would do the same, please, it would make things a little easier. -8. Okay. Finally, there's the graph. All right, so it's asking us to, first of all, this is degree 4. It has how many turning points? How many times does it change directions? 1, 2, 3. There are 3 different turns in it, okay? So it has 3 turning points. The end behavior is down on the left, down on the right, so I'm going to wait there. This is an even polynomial. I'm going to find the zeros. So we go second, trace. We're trying to calculate a 0, choice 2. And then I see the first 0 right here is between 1 and 2, so I'm going to hit 1, enter, 2, enter, and then enter again, and it'll give me that first 0. It's at 1.270, and I'm going to find the other one, 1.27. You guys can write it down in your paper a lot easier than I can keep flopping back and forth, so I'm going to find them both. So now I'm going to go second, trace. The other 0, choice 2, is between 2 and 4, so I'm just going to hit 2, enter, 4, enter, enter, and there we go for the other one, 3.03. I thought it was going to be 3. It looked like it, but we need to go looking in the grapher and make sure we calculate it. 3.03. All right, I'm going to write those down now. I had 1.270, and I know those lines are not big enough, 3.030. This thing has been acting up on me today. Okay, it had 3 turning points. The end behavior was pointing down, so f of x was pointing towards negative infinity as x approached negative infinity. That's on the left side. And f of x was approaching infinity, meaning negative infinity, meaning pointing down, as x approaches positive infinity, which is the right side. This was an even function. And now we're going to find the max. So we go back to the grapher. This right here, guys, look, this is a relative max, and so is this. So you're finding 2 spots. It's not just one. Okay? Relative max and a relative max. Then we're going to also find a relative min. Okay? So where they turn, you're going to be finding those points. That's your first relative max, and then your second relative min, etc. So we're going to calculate, oops, I need to go back to that grapher. I don't know why I just went off of it. Second trace, we're going to hit max, choice 4. The first one is between -2 and 0. So I'm going to type -2, enter, and 0, enter. And then enter again, and it should jump on that little hump. There it is. It's at -0.85, -6.86. All right, so I'm going to go to I want to get that written down. So that was the relative max, -0.85, I forgot now, 6.86. And there's another one. So who knows why these lines are so short. Okay, so we go find the other one. So now I'm going to hit second, again, calculator trace, choice 4. And then I'm going to say this max is between 1 and 4, say. 1, enter, 4, enter. Enter again. all I'm doing again is giving a left-hand bound that I know it's between and a right-hand bound, and then I can find that relative max. This one's at 2.35, 9.55. So I got another max at 2.35, 9.55. Got to write the whole point out. Now we're going to go find that min. The min is this one spot. It looks like it's at about 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, negative 8. Let's see if it is. Second trace 3, choice 3. That thing's between negative 1 and 1. And that is the y-intercept, I think. Yep, it was. It's at, this is essentially 0, guys. Negative 2.277 e to the negative 6. That's like scientific notation. So this number to the negative 6 power, that'd be 0.000002277. So it might as well be 0. Okay, really, really tiny. So 0, negative 8, as I suspected, or it looked like it. That's your min. Okay, the domain for this thing, oh, I haven't sketched it yet, so let's go plot those zeros. Actually, it did the little twist down here, and the min was a little higher, so it did something like this, right? And then the next zero is here, and then it went up to that max, which is about 9.5 to something, 9.5. Right around there. And then it came back through almost at 3. About 3. So that's a sketch of it. Okay, and then the domain is negative infinity to infinity. And the range, though, it tops out. It goes from negative infinity up to the tallest max, which was at 9.55, and it includes it. So we need a solid bar bracket there. Okay, any questions about this problem now? No? All right, we're good. Okay, what do we expect the next one to look like? I hate parabola. So it should only have one turning point. It has a leading coefficient that's positive, so its end behavior should be f of x is pointing up towards infinity, and the left-hand side as x approaches negative infinity, and f of x should be approaching infinity. The graph is pointing up on the right as x approaches infinity. It's an even function, and then now I'll go, what's the domain? We know that right away. Negative infinity to infinity. So that's at least all the stuff I could write down before I look at the graph. Okay, so I'm going to go in now and type it in. X squared, oh, it was 2x squared. Should be fairly thin then. Minus 7x plus 4. Okay, so I want to find, let's see, that will be just one minimum, and I got to find the zero. So let's go calculate those zeros. Second trace, choice 2. The first zero is between 0 and 1. Okay, so it's at 0.72, and the other one is between 2 and 4. .72, and this one's at 2.78. So my zeros 0.720 and 2.780. There is no max. Okay, not applicable. You can write NA, but there is a min, and that's its vertex. And that'll help me with the range. So second, trace or calculate the minimum, choice 3. It's between 0 and 4. I'm just giving quick estimates of nut values that it's between. You can use different ones as long as they give you the right solution. 1.75, negative 2 and an 8. Negative 2.125. Now, it did say to go to the nearest hundredth, so we could have done negative 2.13. The range has to do with that value. So it's going to go from negative 2.13 to infinity. And don't forget it's inclusive. Okay, try another one. Number 3 is oh, I forgot to graph it. That might be good. Okay, so I don't know. I'm just going to estimate the zeros. It's kind of very skinny, isn't it, for this graph on your picture? If you put in 0, you'd be at 4. So it does something like this, and then it comes down to negative 1 3/4, negative 2 1/4. All right, it's somewhere around here. Good enough. Rough sketch. Okay, number 3 is a cubic. I'm expecting it to do a twist. A pretty good one, too. Should probably have 2 turning points. Let's see. Clear that out. We've got x cubed minus 4x squared plus x minus 1. Oh, very nice twist. And it's crossing the x-axis really close to 4. So I'm going to go ahead and calculate that 0. It's between 3 and 5, or 3 and 4 actually. At 3.81, it only has 1 0. It has 2 turning points, and it's pointing down on the left, so f of x is approaching negative infinity. I didn't mean to put a comma there. As x approaches negative infinity. And it's pointing up to infinity on the right as x approaches infinity. It's odd. And let's go find the max and mins. Maximum point looks like it's the y-intercept, or close at least. Second trace, maximum is choice 4. And that's between negative 1 and 1. Okay, I have it guessed for us, and it says it's at 0.13, negative 0.94. Negative 0.94. Aren't those special decimals we keep writing down? All right, minimum. There's a min at 2 something. Second trace, choice 3 for minimum. And we're going to put in, let's say, between 1 and 5. I don't care. 1, enter, 5, enter, enter again. I think I missed. There we go. 2.54, negative 7.88. And then the domain's negative infinity to infinity, and the range is also negative infinity to infinity. Okay, to graph it, 3.8. Maybe I'll do that in red. Ugh. I think, what did it look like again? Okay. So that thing crossed at almost negative, right about there, and then it came down. The lowest min point was 2.5, almost -8. Right around there, and then it went back up. Good enough. Okay, any questions through 3? You just have one more example. Okay, this number 4. 2x cubed. Another cubic. Wow. Minus 3x squared plus 2. Okay, I was hoping for, we should have had something with a negative leading coefficient, but we didn't. All right, this looks like it crosses at about 0.2, and it dips back down. So it has 2 turning points. It's down on the left. F of x is approaching negative infinity on the left as x approaches negative infinity. And it's pointing up. F of x approaches infinity as x approaches positive infinity. This was odd again. Domain negative infinity to infinity, and so is the range. And now find the zeros, etc. It's got 1, 0. And it's between -1 and 0 for x values. I did something wrong, so I better... Oh no, mine just went slow. I had it. Dang it. It just was slow doing it. Don't know why. Choice 2, again, that was between... I can just type -2. Enter. 0. Enter. I don't know why I chose to change it instead of -1, but I did. Yeah, it was very slow. I got -0.680. And that was the only 0. Okay, the max is at 0.2, right? They may check it. Is it 0.2? Okay. And then the min's at 1.1. Okay, so we're good? We need me to go back over how to get those. All right, you have a book assignment. It is on